This video is for section 3.2 in the textbook, and this is all about logarithmic notation. And like the title of the section says, it is all about notation. All we're doing is learning a different way to write something, okay? Basically what we're saying here is that if you have an expression, and this section starts on page 157, so if you have an exponential expression, b to the x is equal to n, then the way to state this logarithmically is to say log to the base b of n is equal to x. Okay? So these two statements are saying the same thing. And all we've done is introduce this notation that what it does is it calls attention to the exponent. Okay? Historically, logarithms were often used to calculate for a variety of reasons. I'll talk about in some of these sections that are coming up in sections 3.3 and 3.4. It's also a way to look at phenomena that grow exponentially. So if you see graphs frequently, let's see, in the financial industry, also the Richter scale and pH calculations. These are all things that are based on logarithms. And a logarithmic scale is something that instead of going 10, 20, 30, 40, and so on, a logarithmic scale on a graph will do something like this. It'll go 1, 10, 100, 1,000, and so on. It'll count up by powers of 10 rather than multiples of something. Okay? If you've seen any of these graphs from the COVID-19 epidemic, frequently what you're seeing are logarithmic scales. Okay? All right. So all the problems in this section are just about going back and forth between these two different notations. So let's take a look at some of these problems. These are on page 160. And we'll just start kind of running through some of these problems. We start off with some logarithmic statements that we want to rewrite using exponential notation. So in problem 2, if we say h is equal to log to the base 7 of 10, then I sometimes remember this by this little circle here, b to the x power equals n. And so here we would say 7 to the h power equals 10. And that's it. That's all I'm looking for in the answers to these problems. All right. Let's look at problem 4. Log to the base 6 of 6 is equal to 1. So that says 6 to the first power is equal to 6. And I've tried to make these statements true. All right. Problem number 6. This one says log of 0.01 is equal to -2. So what's missing here is the base, b, okay? So in most cases, and in all cases for this course, if you are missing the base here, it's usually understood that that means base 10. And so an exponential statement here would say 10 to the -2 power is equal to 0.01. Okay, let's see here. Problem 8 is also in base 10. It says log of 3 is about 0.4771. And so again, we have an implied base of 10 here. And so we would say 10 to the 0.4771 is equal to about 3. Okay. All right, let's look at problem 12 here. In problem 12 it says ln 0.989 is equal to about negative 0.0111. So now in this situation, notice it doesn't say log, it says ln. And that stands for natural log, which means base e. Okay? And so if we wanted to write this exponentially, we would say e to the minus 0.0111 is about 989. Alright, so if you see log with no base, that means base 10 in most circumstances. And if you see this ln notation, that means log base e. Alright, so that's the first group of problems. Let's look at the second group of problems here on the page. Here we've got exponential statements, so like problem 14, it says 10 to the fourth power is 10,000. And the instructions ask us to rewrite this using logarithmic notation. So, what we want to do is write log. Now normally we would write the base down here, but since it's base 10, we can just leave it blank. And then we would just say log of 10,000 equals 4. Okay, let's see here. Problem 16. 5 to the minus 3 power is 1 over 125. So here we do have a base, right? Our base is 5, so this would be log to the base 5 of n, which is 1 over 125, equals the exponent, in this case, negative 3. Okay, let's see here. Problem 18. We've got 8 to the 1/3 power is equal to 2. So this would be log to the base 8 of 2 is equal to 1/3, right? 8 to the 1/3 is equal to 2. Okay, problem 20. 10 to the 0.301 power is going to be equal to about 2. So this would be log to the base 10 of 2 is equal to 0.301. Now, if you want to do this on your calculator, there will probably be some situations where we need to actually calculate some logarithms. So let me show you where those are on the calculator here. All right, let's see here. Let's get the camera to focus. There we go. And then down here on the left-hand side, you can see in the bottom left it says on, and then above that it says STO, and then you get your ln and log keys. So if we press the log button, then we'll see this. And if we want to do log of 2, which is what I was just working out on the board there, log of 2, hit enter, and there it is, about 301, and that's what we've got in that problem. Okay. Now let's finish up this section here. And let's see what we've got here. That was problem 20. So problem 22. Problem 22 says e squared is going to be about 7.3891. And so if we wanted to write this, instead of writing log base e, we write ln. 7.3891 is going to be about 2. And then in problem 24, we've got e to the minus 2 power, and that's going to be about 0.1353. And again here, instead of writing log base e, we write ln. 0.1353 is going to be equal to about negative 2. Okay, let's see. Before we wrap things up, let's take a look at these on the calculator. And just double check what we're doing here. There we go. And so the first one that we've got there, so first we hit the LN button, and then we'll put 7.3891 and press enter. And there's our answer, just about 2. Okay, and then we'll do the other one, ln of 0.1353, and again, just about -2. And those are approximate because they're irrational values. Okay, so that's it for this section. Like I said, this section was just about introducing this notation about logarithms. When we get to the next section, 3.3, we'll use this notation of logarithms to solve equations. So I'll make another video for that, and we'll see you then.